5.4, solving rational equations. This lesson is about solving rational equations. They're kind of similar to what we did when we tried to say solve for an equation that has fractions in it. So let's just do a little bit of a review first. For example, if I asked you to find out or solve for x, and I gave you this equation, 2 over 3 equals x over 4. How would we solve for this equation? Well, we would multiply both sides by the common denominator of 3 and 4, which is 12. So we'd multiply both sides by 12, so you don't change the integrity of the equation. So both sides get multiplied by 12. 12 divides by 3 to give you 4 here. 12 divides by 4 to give you 3 here. And you get 8 equals 3x. You divide both sides by 3, and you get x equals 8 over 3. Now some students might do it a little differently. They might see it as 2 over 3 equals x over 4. And you may have learned like cross multiply it. So you multiply these two, and you get 3x equals 8. And you divide both sides by 3, and you get x equals 8 over 3. So both of those methods are correct. The first one is the most correct one than just cross multiplying, but I just showed you both ways. Let's try another example. 2 over 3 equals x over 2 plus 1 over 5. Okay, so in this one, the common denominator for all of them is for 3, 2, and 5 would be, or let's just try to let's just bring x over 2, let's leave it there and bring the fractions together. So it's 2 over 3 minus 1 over 5, and then find the common denominator for 3 and 5, which is 15. So 3 5s are 15, 2 5s are 10, 5 3s are 15, 1 3s are 3, equals x over 2. So 7 over 15 equals x over 2. And then we can cross multiply and write 15x equals 14. Divide both sides by 15, and you have x equals 14 over 15. Okay, now let's try another one. 2x plus 3 divided by x plus 4 equals x over 4. It's kind of having the variable x in, this binomial here, an x and plus 4 here, and x here. So you have several parts, you have x. So what you can do is, always try to eliminate the denominator, find the common denominator. For these two, it's 4 times x plus 4. So you can multiply both sides by 4 times x plus 4, which is the common denominator, and then try to eliminate the denominators that way. So let me just do that here in a different color. Let's say this is multiplied with 4 times x plus 4, and this also multiplied with 4 times x plus 4. So when you multiply both sides of the equation by the same quantity, it doesn't change the equation. So that's what we're doing here. X plus 4 and x plus 4 divide to give you 1, so they cancel out. This 4 and 4 divide to give you 1, so they cancel out. So on the left side, you're left with 4 brackets 2x plus 3, don't forget the brackets, equals x brackets x plus 4. And in our next step, we open up the brackets, we use the distributive property, and get 8x plus 12 equals x squared plus 4x. And we can bring them all to one side, so 0 equals x squared plus 4x minus 8x minus 12. So you end up with a quadratic equation, x squared minus 4x minus 12 equals 0. If it's factorable, we can factor. If it's not, we can use the quadratic formula. This one's factorable as x minus 6 and x plus 2. So x minus 6 could be 0, or x plus 2 could be 0, which means x is 6 or x equals -2. So this one has two solutions because it's a quadratic equation. The two values of x that satisfy this equation, right? So when we're trying to solve a rational equation, we multiply by the lowest common denominator and then solve the resulting polynomial equation. So if we were asked to solve the rational equation 4 divided by 3x minus 5 equals 4, what does it mean to solve it? What it means is we're trying to find, if we were trying to put a graph to this 4 divided by 3x minus 5, we will get this graph in green here, this transformation of the reciprocal function. And on the right side we have 4, which is equation of a horizontal line, gx equals 4. And when we say 4x divided by 3x minus 5 equals 4, we're actually finding the point of intersection of these two functions, of f of x and g of x. And it meets at this point of intersection, which is 2, 4. So when we're trying to solve this, we actually find the value of x, which in this case is 2. But we are going to do it algebraically always, but I just wanted to show you graphically what that looks like. So our rational equation is 4 divided by 3x minus 5 equals 4. You can multiply both sides by 3x minus 5 to eliminate the denominator. So on the left side, these cancel out. You're left with just 4. On the right side, you have the 4. You distributed it into brackets here. So you get 12x minus 20. 12x equals 4 plus 20, which is 24. You divide both sides by 12, and you get x equals 2, which is also what you got here when you looked at the point of intersection of f of x equals 4x divided by 3x minus 5, and the function g of x equals 4. The point of intersection was 2, 4. So the x value at that point of intersection is what we are solving for when we solve the equation or this rational equation algebraically. Let's try other examples. Let's try 2 divided by x plus 1 plus 5 equals 1 over x. You can bring the terms with the x together. So 2 divided by x plus 1 minus 1 over x equals -5. The common denominator for the left side is x times x plus 1. So we're going to multiply this with an x. So you multiply the 2 also with an x. And then this gets multiplied with an x plus 1. So you multiply 1 also with an x plus 1. So in the numerator you have 2x minus x plus 1. Don't forget to put the brackets because there's a negative outside. Equals -5. When you open the brackets, you get 2x minus x, which is x minus 1 divided by x over x plus 1 equals -5. So x minus x. And then we can now cross multiply. So when you multiply these two and these two, we get 1 times x minus 1 is x minus 1 equals -5x times x plus 1. So x minus 1 equals -5x squared minus 5x. Let's bring all the terms to one side. So on the left side, we have 5x squared plus 5x minus x. So we brought this to the side of this is plus x minus 1 equals 0. these two terms are alike, we can add them up. So 5x squared plus 6x minus 1 equals 0. So here we have a quadratic equation. If it's factorable, we would factor it, but this one, to find factors of -5 that add to give you +6, it's not possible by factoring. So -5 would be 5 times -1, or -5 times +1. They're not going to add to give you 6. So we have to use a quadratic formula. Let's do it up here. Let's continue down here. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a. So x equals -6 plus or minus square root of, well, what do we get in brackets there? We get 36 plus 20, which is 56 over here. And that will work out to, if you try to round it to one decimal place, it works out to approximately, or two decimal places, 0.15, or x equals -1.35. So you have two solutions for that equation. Let's try the next example up here. X minus 5 divided by x squared minus 3x minus 4 equals 3x plus 2 divided by x squared minus 1. It's easier to kind of find what we need to multiply both sides with if we can factor the denominators. So we're going to rewrite the denominator as, because this is factorable, x minus 4 times x plus 1, right? -4 times 1 is -4. -4 plus 1 is -3. And the denominator for the right-hand side also is factorable. It's a difference of squares. It's x squared minus 1 squared, which can be factored as x plus 1 times x minus 1. So what we can see is we can find the common denominator. We can kind of try to eliminate the denominators by multiplying both sides with the same binomials. So let's multiply both sides with an x minus 4, so that'll get rid of this, and x plus 1, that will get rid of this, and an x minus 1 to get rid of the x minus 1 here. So we're going to do the same thing on this side. So multiplying these three binomials on the left side, we need to do the same thing on the right side here. So you're going to multiply 3x plus 2 with x minus 4, x plus 1, and x minus 1. So what happens when we do that, these two will divide and cancel out. These two will cancel out. And on the right side, x plus 1 and x plus 1 cancel out, x minus 1 and x minus 1 cancel out. So that way we are ending up with, on the left side, just an x minus 1 and an x minus 5. Denominator is just 1, equals 3x plus 2 times x minus 4. So we can multiply this, x times x is x squared minus 5x minus 1x plus 5 equals 3x squared minus 12x plus 2x minus 8. And on the left side, this simplifies as x squared minus 6x plus 5. On the right side, this simplifies as 3x squared minus 10x minus 8. We bring all the terms to one side, and we get 0 equals 3x squared minus x squared, which is 2x squared, negative 10x plus 6x, which is negative 4x, negative 8 minus 5, which is negative 13. So here we have a quadratic equation which is not factorable. So we are going to use the quadratic formula. So x equals minus b, which is plus 4, plus or minus square root of b squared minus 4ac divided by 2a. So that works out to 4 plus or minus square root of 120 divided by 4. And we can solve to 2 decimal places. We get x equals 3.74 or x equals negative 1.74. So those are the solutions for that rational equation. We'll try now some application questions. Rima bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each shirt. How many t-shirts were in the case? So we have to now come up with an equation with these numbers. So we need to have a let statement. The question's asking how many t-shirts. So let's use that to define our variable. Let x represent, let that be the variable, represent the number of t-shirts. Originally in the case. Okay, so she bought that many t-shirts, an X number of t-shirts for $450. She kept 2 for herself and then she sold the rest and made a profit of $10 on each shirt. So it's a profit question, right? Where profit is equal to revenue minus cost. We're going to use this relationship between profit, revenue, and cost to come up with the equation for this word problem. Now, because she's, she bought these many shirts, we need to find the profit per shirt. Profit per shirt is equal to the revenue that Rima had per shirt minus the cost per shirt. So in this case, how many shirts did she sell? Rima sold X minus 2 shirts because she kept 2 for herself, right? So when we try to find the profit, in this case, it says she made a profit of $10 on each shirt. So this part here, this profit per shirt is exactly $10, right? And the revenue she got for selling it is $560. So the revenue per shirt will be $560 divided by how many shirts did she sell? She sold X minus 2 shirts. And the cost that she had was $450 for how many shirts? For X shirts, because she bought X shirts and she sold X minus 2 shirts, right? And the profit per shirt. So this is our rational equation, which we can now solve for X. Let us find the common denominator on the right side, which is going to be X times X minus 2. So we are going to multiply, this equation with an X and this also with an X. This one with an X minus 2, so 450 multiplies with an X minus 2. So in the numerator we have 560x, and in the and here we have minus 450x plus, because there's a minus here, minus and minus make plus 2. We can now cross multiply. So we can multiply 10 times that and 1 times that, we get 10x times x minus 2 equals 560 minus 460 is 110x plus 2. On the left side, we have 10x squared minus 20x. And we can bring these terms to the left side. Minus 110x minus 2 equals 0. So simplify this as 10x squared minus 130x. Did I make a mistake? I think I did. Because I didn't multiply. When I distributed the 450 here, I made a mistake. 450 times x, so right here. The 450, negative 450x was fine, but then there was a negative 450 times 2. I only just did minus and minus. It did plus 2. So I'm kind of off very much over here. There should be negative 450 times negative 2, which is positive 900. Okay, so it's that number is not right. So got to change that to a 900. And when we bring it here, also it becomes negative 900. So you have there. Now it makes, so that's 10x squared minus 130x minus 900 equals 0. We could divide both sides by 10 just to work with smaller numbers. So we get x squared minus 13x minus 90 equals 0. This again is a quadratic equation that cannot be factored, so we're going to use the quadratic formula. So x equals minus b, which is positive 13, plus or minus square root of b squared, which is negative 13 squared, minus 4 times a times c, divided by 2a. That is x equals 13 plus or minus square root of 529 divided by 2. So you get 2 solutions. And you get x equals 18 or x equals negative 5. So you have 2 solutions, but x in this case represents a number of t-shirts that were originally in the case. So you can have a negative number of t-shirts. So this one is what we call inadmissible because it makes no sense for the word problem. So we're going to take this answer. So therefore, there were 18 t-shirts in the case. Okay, and she kept 2 and she sold 16 of them. So that's the answer. Let's try one more word problem. Juan and Mark together can cut the lawn in 45 minutes. If working alone, Juan takes 11 minutes longer than Mark. How long does each take to cut the lawn by themselves? So together they cut the lawn in 45 minutes. But if they work alone, Juan takes 11 minutes longer than Mark. How long does each take to cut it by themselves? So I've just made a table here in my solution to kind of write down all the numbers given to me in the word problem. I need to define a variable here. And this how long statement kind of gives me a clue to what my variable should be. So I'm talking about time. The question is asking me to solve for time. So my variable x should represent time. And there's 2 people here. So one is the time that Juan takes to cut the lawn by himself, and the other one is how much time Mark takes. So since Juan takes 11 minutes longer than Mark, I'm going to define the variable in terms of Mark. I'm going to say let x represent the time taken in minutes for Mark to cut the lawn, right? So if x is the time that Mark takes, then x plus 11 would be the time taken in minutes for Joanne to cut the lawn. So just using that one variable, I'm able to kind of represent both of their times. So Mark's time in minutes is X, Joanne's time is X plus 11. And I'm going to look at the fraction of the lawn cut in 1 minute. So if I consider how much of work is completed in 1 minute for Joanne, it's 1 over X plus 11. And for Mark, it's 1 over X. Okay? So the reason I need the fraction is that I can say that together they can cut the lawn in 45 minutes. They've given me this time here. It says that they work together. They can finish, cutting the lawn together in 45 minutes. So it would be that, how the amount of or fraction of the lawn they cut if they work together would be 1 over 45. So when I consider this fraction of the lawn that's cut, I can equate that to the sum of their work in that 1 minute. So 1 over 45, which is the fraction of the lawn that they cut in 1 minute, will be equal to the sum of the fraction that each of them cut in 1 minute. So 1 over X plus 11 plus 1 over X. So this helps me write an equation that relates the amount of work that they can get done in 1 minute separately, and that adds up to the amount of work that can get done in 1 minute if they work together. So I have a rational equation here, and I need to solve for X. I'm going to, for the right side, the common denominator is X times X plus 11. So this gets multiplied with an X, and this gets multiplied with X plus 11. So I have here 1 times X is 1X plus 1 times X plus 1 is 1X plus 11. So 1 over 45 equals 2X plus 11 divided by X squared plus 11X. I'm going to cross multiply, and I get X squared plus 11X equals 45 times 2X plus 11. So that works out to X squared plus 11X equals 90X plus 495. So I'm noticing that I'm coming up with a quadratic equation here. I'm going to bring them all to the left side. X squared plus 11X minus 90X minus 495 equals to 0. Simplifies this to X squared minus 79X minus 495 equals to 0. Again, I'm ending up with a quadratic equation that I cannot solve by factoring, so I'm going to use the quadratic formula. So the quadratic formula is this works out to X equals 79 plus or minus square root of 8221 divided by 2. So X works out to 84.8, or X equals negative 5.8. So this value is inadmissible because you can't have a value for time that's negative. So we're going to take this value. So this would be the time Mark takes, which is approximately, if you round up, about 85 minutes. Therefore, Mark takes approximately 85 minutes, and Joanne takes 11 minutes longer. So 85 plus 11, which is 96 minutes approximately. to cut the lawn by himself. Okay, so that brings us to the end of this lesson. We can now work on the